So just a few parting thoughts before we finish this section. This has been a big section. We've covered a lot. Okay. We've covered 4 different random sampling methods. We actually have not covered the most common sampling method. And that's because it's not a random sampling method. It's convenience sampling. Okay. How does convenience sampling work? You sample what's ever convenient. Okay. Importantly, it is not random. And for that reason, we usually try to avoid convenience sampling. So let me give you an example. So say we're back in that classroom with those 30 students that we've been talking about the whole time. Okay. The instructor needs to sample 6 of them. Now, instead of using one of the random sampling methods we've discussed, instead he just looks at the front 6 students and says, like, you 6, you're in a group. Why did he do it? Because it was convenient. It was easy. Okay? And it might be that that group is a very good group of students for whatever we're doing. Okay? But it was not random. And so there's a good chance that it won't be a good group of students. It's harder to predict. Okay? Because it's not random. Okay? So we try to avoid this method. Now, I should say that convenience sampling, it's not random, and so we try to avoid it. We don't have as much confidence in the results, but that doesn't mean that the results are guaranteed to be off or to be bad. It just means that we have a harder time having confidence. It could be that the results are actually quite good. And generally, some data is better than no data. You could get in a little bit of trouble with that if you really try, but generally, some data, even if you use convenience sampling to gather your data, some data is usually better than no data. Okay? With that said, we try to avoid this. Random sampling is the gold standard. We like random sampling because it's more likely to make sure that all the characteristics of the population are present and that the sample will accurately reflect the population. Remember, the idea is we want the sample to tell us about the population. Sampling is actually the most important part of statistics. Okay? If the sample is bad, if you have a bad sample, then no amount of good math will save you. Okay? You cannot have good statistics without a good sample. So sampling is the most important part of statistics. It is the foundational part. It's what you start first, and it's most often what is done wrong. Okay? Convenience sampling is very common because it's easy. And again, it doesn't guarantee you're going to get bad results, but it makes it harder to have confidence in the results. Okay? All right. Another thing we should talk about is sample size. Generally, the bigger the sample, the better information it's going to give you. Okay, so for sample size, bigger is better. The larger your sample, the more members in your sample, the more likely your sample will accurately reflect the population. I mean, if you think about it, let's go to the extreme. If you have a sample of only one individual, maybe just by chance, you sample the President of the United States. If you're using that as your sample, now you think everyone in the whole United States is the President. Okay? One person is not a good sample. And even if you sample 10 people, what if the President of the United States is in that group of 10 people? It's unlikely, but it's possible. Now you think that 1/10 of all people in the United States are presidents. It doesn't work that way, right? The larger your sample, the more likely that your sample will be an accurate reflection of the population. Bigger is better. Now there are limits, right? You could just sample the whole population, but that kind of defeats the purpose. It turns out that there are diminishing returns. 100 is better than 200, and 200 is better than 100, and 300 is better than 200, but 300 is not as much better than 200 as 200 is than 100. I hope that makes sense. You get more benefit from going from 100 to 200 than you do from going to 200 to 300. 300 is still better, but you don't get as much of a benefit. Okay? So there are diminishing returns. And you have to weigh your sample size with things like the cost of sampling things. Okay? There's also sample variability. This is very important to understand. If you have variability, there we go. If you have two people that get two different samples from one population, those two samples will be different. Okay? And so what they will tell you about the population will be a little different, probably just a little. Okay? We see this in the news all the time. If you pay attention to different political polls, one poll may say candidate A is ahead by 5 points, and the other poll will say candidate B is ahead by 2 points. That's natural variability. Okay? It's to be expected. The sample does not tell us perfectly about the population. It tells us, gives us an idea and about what's going on here. Okay? So, variation between different samples in the same population is natural and expected. Too often we think of statistics as giving us an exact answer. Statistics is not about exact answers. It's about getting close and seeing trends. Okay? It is not about being exact. Statistics does not give us the power to be exact. And that's because of the variability here. Okay? One sample could give us something that's close but not exact. Another sample could tell us something else that's also close but not exact. Both help us understand the true picture. Okay? So just be aware that there's variability. Okay, one more thing. We've talked about 4 random sampling methods, right? Simple random sampling, stratified sampling, systematic sampling, cluster sampling. And these are 4 great methods. Random sampling is the gold standard, but it is not always possible. We'll often see this when we're sampling people. We cannot force someone to participate in a sample. It is not ethical. And so random sampling in its purest form doesn't work with people. Okay? That doesn't mean we can't sample people, but I just want you to be aware that the sampling methods we've learned today are somewhat idealized. They're the ideal, they're the hope, but they don't always work in practice. Real statisticians use more complicated methods to try to sample groups where we can't do a perfect random sample, and to try to make that sample be an accurate reflection of the population. Even our best samples of people, they vary more than true random samples, and they don't reflect the population quite as well as we hope. Okay? And that's to be expected because we can't do a perfect random sample. Doesn't mean the data is useless, but it just means there are limits in some of these situations. Okay? So we've learned the ideal, but just be aware that in more advanced statistics, there are other things that there are other situations that we need to take into account. Okay?